Now we're live. All right. I don't think we were live before in doing that intro, but now we are up and at 'em here with Troy and Steve. What's going on, everybody? While we get settled in here, I'd love everybody to just kind of check in. Let us know where you're from here in the comments. There's a couple comments coming in. Hey, Karen, White Davy Garden and Warm Farm. Did I say that right? There's White. How do you say how do you say that, Karen? Is that White Davy Garden and Worm Farm? Let us know in the comments there. Everybody else, please check in. Let us know where you're coming in from. Looks like a nice showing here so far. Cool. We'll just give a few more seconds while people sign in and get going. Okay, a few more people showing up. Cool. Awesome.
Hey, Samantha.
Let me go to the Hey, I know that lady. There's Laura. Laura from Worm Return in Pittsburgh. Very cool.
Hey, Laura.
Doing some compost hauling there. Hey, Nana, out there in Vancouver. Oh man, Victoria, which is absolutely beautiful place. I would love to be spending more time out there. North Florida, very cool. Tennessee. Troy's a Tennessee guy, or was. So
nice.
Awesome. All right, everybody. Well, I tell you what, let's just go ahead and get started. Everybody keep saying hi in the comments. Let us know where you're from. In the meantime, I'm just going to get started, let you know what today's about, do a little bit of few housekeeping items. We'll turn it over to Troy. I'm going to have a couple questions for Troy at the end. Compost Tea is not really in my wheelhouse. It's not really been in the Urban Worm Company's wheelhouse until Troy came along. But now it's something that we want to be able to give people great content on. And so, yeah, I'm excited to have Troy here today. I'm excited to have him as part of Urban Worm Company. And yeah, can't wait to get started. So the guy on the right, the one with hair, is Troy Hinke. You've probably heard of him from various places. I'm going to get this a little bit wrong, but he used to work at the Rodale Institute, used to work with Elaine Ingham, the soil food web expert. The thing I like to brag about here is that Troy worked with Elaine, not just for Elaine, or didn't just study under Elaine. I mean, he did study under Elaine, but it was working alongside her at Rodale, which is a little different and something that Troy should be proud of, and that I know I'm proud of too. I first met Troy at the, I believe, 2019 or 2018 Vermiculture Conference in North Carolina, which is going on again this year in October. If you're part of my email list or part of our email list at Urban Worm Company, you've heard about it. You're going to hear about it again. But the Vermiculture Conference has people coming from all over the world, from all over academia, all over the business world, all over anybody who actually wants to get into the idea of worms, worm breeding, worm composting, organic agriculture. There's people from all over that come to this thing. It's a lot of fun. It's a 2-day conference, and you should really sign up. But I met Troy when he spoke a few years ago at that conference. I was impressed with not only his presentation, but his questions for other presenters, which I felt were really you had to be educated in something to know what Troy was asking. And so I was like, okay, this guy is somebody. He's not just a schlub like me. So I was impressed by Troy. We've stayed in touch on and off again. Troy reached out. I forget what it was about, but I said, hey, how's it going up there? Troy happens to live about an hour away from me right here. And he goes, I've had some kind of job changes here. I'm looking for something else. And I said, okay, the stars are aligned. I need more brain power here than what I can provide. And so I want to I want Troy to be part of Urban Worm. And so I said, I remember when I called you a few months ago, I said, I got to hire you. I mean, I feel like this is a no-brainer where I've got to bring you on board, and I'm glad to have him. He's been doing some great content for us here on Compost Tea so far. We're going to branch out into more soil-specific stuff or soil food web, kind of talk about all the kind of players in the soil food web. And he's going to end up helping us branch out beyond just worms. Troy knows worms really well, but he knows soil a lot better than I do. So love having him aboard. So one thing about Troy, real fast, Troy, you're probably tired of hearing your own name here, but Troy's going to be speaking at the NECAN Chicago convention June 10th and 11th. So NECAN, I believe, stands for Northeast Cannabis.
New England.
Chicago is, what's that?
New England.
New England Cannabis. Now, of course, Chicago is not New England, but close enough. He'll be speaking there in June on living. Can you say what you're saying? Living soils, growing in living soils. Is that correct?
It's living soils. I forget the rest of the title that I named it, but it's going to be how to, basically use compost, vermicompost, compost tea, mycorrhizae to grow biologically, farm biologically, and use nature rather than chemicals for growing cannabis and hemp.
Gotcha. Well, I'm going to be there, and I will probably only be able to absorb a little bit of what you talk about, but you're going to be delivering some good stuff. So I look forward to going out to Chicago. So if anybody's out in the Chicago area and wants to go to the NECAN conference, we're going to be there. All right, so let's get to today's topic, which is compost tea. Compost tea is sort of one of those things that sort of exists in theory. People like the idea of it, but they don't know, okay, how do I get started? And really, what's the recipe and what's the process for making it? Like, you tell me that I need soluble kelp, but how much soluble kelp? You tell me I need to apply it to plants, but how much should I apply it to plants? So those are things that we're going to cover today to, I think, give you some actionable advice on really how you can use it and what some of the, how you're going to make it, and then kind of how you're going to use it. So cool. Let's get down to it. What I'm going to say is Troy's going to give his presentation. I'm going to ask him a few questions that I have sort of preloaded. We're going to open up the floor to you guys for any topic you want to talk about, whether it's compost tea, worm tea, which was really worm compost tea, worms, worm bins. I joked with you guys that if you want my advice on how to scold a child with great fervor, I can try to do that as well. Anything you guys want to talk about, we're here to talk about. So, and then we'll wrap up at the end. So at this point, I'm going to turn it over to Troy. I'm going to shut up for a while. He's going to share his screen and we're going to get going.
Hey, everybody. I'm going to get my screen up here and I'll start sharing with you. I've got a little slideshow presentation that's just a few pages long that we can go over. But so I've been making compost, brewing compost tea, working with the soil food web for 11 years now. And give me 1 second. So all of the information that I'm giving you is based off of past 11 years of brewing compost tea, looking at it underneath the microscope, checking my results, and finding out what's best for recipes and things like that. Sorry, I'm not the most, I am really into soils and soil food web and worms, but tech's not my thing as much as it is Steve. So I'm sharing my screen right now. Hold on.
All right. In the meantime, I'm just going to say hi to some of you folks. Hey, Worm Wrangler there. And hey, I shared an Uber ride with you, didn't I? Hope you're doing well. Hey, Mark. Hey, Sam. Hey, Nancy over there in PA. All right. Troy's ready to go. I just want to say hi to a few more people. Richard is overnighting in Columbus, which is where I did my first live stream when I was there on an overnight with Southwest Airlines. That's kind of cool. Richard, are you flying for somebody yourself? That is pretty cool. Jack, out in Idaho, how's it going? I hope your castings are doing well. Man, Vicky in Fort Worth, good to see you. Robin in Arkansas, awesome. Okay, I'm gonna get out of the way again. Troy, I'm gonna go ahead and take some stuff off the screen so you've got more kind of real estate to play with, and we can get started.
Cool, thank you. So I'm going to mainly leave my screen up where I'm not even seeing you. I'm just going to have my presentation up and talk about it. So here we go. So first, when it comes to compost tea, we need good ingredients, and it starts off with quality water. So the best thing that you can use is going to be rainwater or well water, possibly. If you have chlorine or chloramine in your water, you would want to treat either of those by off-gassing chlorine by leaving it out. If you know, most people don't know what their water company uses, but they know that there's either chlorine or chloramine. Humic acid, any acid can neutralize the effects of chlorine and chloramine. So I don't have a chemistry background to be able to explain how that works, but I know that they do neutralize the ions in it, so you don't have to worry about them having any debilitating effects on your microorganisms. So humic acid is a food that we are going to be talking about in a few minutes here, and we use humic acid. That's an acid, and you can use that to neutralize chlorine and chloramine. Some people, I just learned that in other countries, humic acid isn't readily available. So another thing that you could use is citric acid, which is going to be a natural source, and it just takes a little bit. So we'll be discussing that too in a few moments here. And then when it comes to water, I also had a comment about well water with a water softener. So if you have a water softener on your in your lines, then it's likely using salt, and we don't want to be having salt in the water because it could have a bad effect on both plants and microorganisms. So you wouldn't want to use water that's from a system that uses salt. And then also we're going to need air in our compost tea. The air is going to provide oxygen in the brew so that we can keep it aerobic and brew for an extended period of time. And then we were going to need to have vermicompost or compost, obviously. And I'll stress that compost tea is made with compost. It's not made with manure. It's not made with soil. Those would be manure teas or soil teas. Compost tea uses compost or vermicompost. And compost tea is also not the stuff that falls out from the bottom of your worm bin. That is leachate, and it's a questionable substance. That's a talk for another time. And then on top of the water, air, and compost or vermicompost, we're going to need foods for microorganisms, and we're going to be getting into those foods in a few minutes here. So the idea here is that we're going to be feeding microorganisms, giving them more energy to reproduce and double their populations on top of each other over a period of time, to where we're going from, say, 1,000 microorganisms to 1,000,000 microorganisms. So foods for compost tea recipes. A bacterial food is unsulfured blackstrap molasses. And if you're wanting to get more bacteria in a brew, you can use just a tiny bit of this. So in a 5-gallon brew, I would only use like 1 teaspoon of unsulfured blackstrap molasses. We're working with tiny little microorganisms here that don't take much food, and you really don't need to use much. And overfeeding the microorganisms is going to likely cause your brew to go anaerobic or just kind of get out of control. And if you were to also put a lot of bacteria, just straight bacteria without their predators out onto the soil, you're going to have pulses of nitrogen pulses that are going to feed weeds and give you more weeds in your lawn, which is something most people don't want. And with the other, that's bacterial food. With some of these fungal foods, they're also going to feed bacteria, and normally we have a good amount of bacteria anyway. So it's generally unnecessary to use any bacterial foods because we're going to be having enough food for them and just having enough bacteria in general. We're trying to get other microorganisms going more in our brew. So I usually don't use any bacterial foods in my brew. I am just strictly using fungal foods. So when it comes to fungal foods, there's humic acid. That's number one. I always use humic acid simply because it's going to take up any chlorine or chloramine if you use city water, and it's going to help plants to take up nutrients in the soil and helps in different ways in soil. And humic acid is actually, it's a natural substance. It's from the humidification process where you get humus, which is the very fine, completely broken down like compost. It can't break down anymore. And part of that process also creates humic acids and fulvic acids. So humic acids is the most prevalent acid like that in humus, in organic matter in the soil. Humic acid, so both humic acid and soluble kelp, which is the next one, come in a powdered or liquid version. Both work well. it can be a bit more difficult to mix the powdered version in. So I like to use the liquid, but also if you're getting it shipped to you via whatever off the internet, you're going to be paying for a lot of water to be shipped if you're getting the liquid solution. So the powdered solution, you can get more bang for your buck, both by you being able to use a little bit less and in the shipping there. So I like either liquid or powdered. I'm not going to say either one. Liquid does mix in better, and you can go a lot faster if you're in a hurry to make up a solution of compost tea. And then we have soluble kelp. So kelp's going to come in different forms. Kelp meal is out there. It's something that you can sprinkle in your garden to add nutrients and micronutrients and minerals. But kelp meal is going to be a little too big and granular for our brew, where it's not going to break down in the water, and a lot of it's going to be taken out with the sediment in the end. So it's better to get soluble kelp, where it's going to mix in with the water and be able to be sprayed out onto your garden, and more of it's going to reach your soils and plants. So I like to use both of those, and fish hydrolysate is the third one. I generally stick with these three. Fish hydrolysate is different from fish emulsion, so both of them can be found in garden stores. Generally, you see fish emulsion more because it's more inexpensive, and most people don't like to spend a lot of money, and you can buy it for less. With fish emulsion, they're taking the oils and the fats out of the fish and then blending it up so that good proteins and amino acids that are going to help to feed fungi in the soil are taken out, and you're left with the rest, which it's not such a bad thing, but we're trying to feed fungi, so it's better to have fish hydrolysate. Fish hydrolysate is basically a fish in a blender with maybe a little bit of water, just blended up fish, so you get the entire fish, including the oils and the fats. And then feather meal is another source of food for fungi. Feather meal is the highest source of organic nitrogen that you can get, so it is going to help add nitrogen to your brew. The only thing is that feather meal is a meal, so it's a bit granular, and it's going to help to feed fungi in your solution, but some of it's also going to get filtered out when you empty your brewer. And then steel cut oats are another fungal food. I generally don't use steel cut oats because I find that when I'm brewing, according to the times that I've had in the past, it seems like in those brew times, when I use steel cut oats, I tend to get more anaerobes that come up. I'll have more ciliates that come more quickly, that's something I'm not wanting. So I tend to stay away from steel cut oats. If you're just doing maybe a quick brew and not going to leave it on a full time, you could use them. But yes, I generally stick with humic acid, soluble kelp, and fish hydrolysate. And then I mentioned we want to keep foods to a minimum. So in a 5-gallon brew, I'll use 1 tablespoon of humic acid, 1 tablespoon of fish hydrolysate, and 1 tablespoon of soluble kelp. Super minimal foods, just a few tablespoons in 5 gallons. Or in 50 gallons, I'll do half a cup of all those, half a cup humic acid, half a cup soluble kelp, half a cup fish hydrolysate. And as I mentioned previously, these are tiny microscopic beings that we're feeding. So keep the foods to a minimum. A lot of people will get foam on their brews, and for some reason, YouTubers have seemed to think that foam makes a difference, and that means your brew's done or it's good. Foam makes no difference, and it generally means that you've used too much foods. You probably put too many foods in your brew, and it's kind of like when you blow through a straw into milk and it creates those bubbles. So this fish hydrolysate has these thick substances and proteins that are going to bubble up when you stick air on it. So in our compost tea brew, we're adding foods for bacteria or fungi, but you're likely not going to get reproduction of fungi. The main things that are going to have reproduce are bacteria, which can double anywhere between every 12 minutes to 24 hours. And that's all dependent on mainly temperature, but it also can be dependent upon pH. But mainly where we're at temperature wise, the hotter it is, the more reproduction you're going to get. So, you know, when you have a refrigerator, you put things in the refrigerator at lower than 40 degrees, because less than 40 degrees, it really minimizes bacterial reproduction. So they're not able to, you know, get on your food and break it down and reproduce. So above 40 degrees, you know, and the warmer you get, you're going to have more reproduction. And then with more bacteria, you're going to get more of their predators. So protozoa are going to reproduce. Protozoa are made up of flagellates and amoeba. Those are the ones that we're wanting to get. Those are the aerobes that we're wanting to get. So like I said, bacteria is a food source for them. So the more bacteria in your brew, the more protozoa you're going to get. So these are the organisms that, you know, if you were to put this on a microscope, both before and after, you're going to see those things increase in populations. And then for a pro tip, I like to add a handful of straw to increase protozoa. This is based on Jeff Lowenfeld's book, Teaming with Microbes. He mentions doing a protozoan infusion, but he uses green plant material and puts it on water to brew to increase the protozoa. So the idea is that you're getting a bacterial boom, which then creates a protozoan boom. And I'm taking that protozoan infusion and mixing it in with my compost tea brew. So that's upping the numbers of protozoa. And it seriously only takes a handful. Like if you've got strands of straw that you're pulling off that are like that, you know, maybe you only need like 20, 30 strands that you put on the bottom of a 5-gallon bucket or in your brew bag. So to get ready for compost tea brewing, we want to prepare the water, which means we want to get it to ambient temperature. We want to brew compost tea at ambient temperature, at the same ambient temperature as the plants that we are applying the compost tea to. So if you're going to be doing it outdoors, you want to brew outdoors. If you're applying to a bunch of plants that are in a greenhouse, brew in the greenhouse. If it's plants that are indoors, brew indoors, but be at the same ambient temperature that you are applying it to the plant, or you want the water at the same ambient temperature as that's what you're applying to the plants. And then you want to off-gas chlorine or use humic acid to treat chlorine and chloramine. So then once we've got the water all ready to go, I just realized that I didn't put to add foods on here. So we've got the water ready. We want to mix in our foods. I'll add my foods in and I like to stir it as I go, or if I'm in a hurry, I will go ahead and put my air pump in the water and then add my food so that the air pump is helping to churn that. A lot of times, I don't know how many of you are into biodynamics, but in biodynamics, they when they're mixing up preparations in water, they create a vortex, and then they break that vortex and stir the opposite direction. And the idea is to like get opposite energy forces into the water. I dig that. So a lot of times I'll do that when I'm mixing in my foods, and I'll stir it, create vortexes in different directions. It's just kind of a little thing to mention. And then you're going to want to put your compost in your brew bag. So if you're doing a 5-gallon brew, if you've got vermicompost, it really only takes like 2 to 4 cups of vermicompost in a 5-gallon brew. If you're using regular compost, I would use a little bit more, like 3 to 5 cups. But it doesn't take much compost to water ratio either. So a few cups in a little brew bag. You want to put your brew bag in the water and don't zip it up or don't close it. Leave it open and stick your hand in there. And I'm going to switch over to the stream so I can make sure that I'm on camera and see this. So reach in your brew bag, squeeze the compost, break up any aggregates and chunks. We're trying to expose as much surface area as we can here to the water so that we can extract microorganisms from those surfaces. So, I'll take my brew bag and like press the compost up against the sides of the brew bag, trying to get tiny particles to come out. And then I'll zip up my brew bag and like just work it between my hands, squeeze it, roll it, work it, get all that stuff broken up as much as you can. So then when you're done massaging the compost, you got your bag zipped up, hang it on your, on your brewer that you want to, and let it go. So you've got your air on, you've got your air pumping into the water, you've got your compost in there, your foods are already mixed in. And then these brew lengths, I'll stress, are our rule of thumb. And these brew lengths are based on the recipe that I just gave you. So if you're using more foods than this, then you wouldn't want to go off these brew times. This is for using minimal foods. And again, it's a rule of thumb because temperatures fluctuate so rapidly. So this chart on the side here shows the average 24-hour temperature. And when I'm referring to the average 24-hour temperature, I'm thinking of that as in like last night's low and this night's high. What's the middle ground in there? So in the spring, in April, depending on where you're at, wherever, I guess the northern hemisphere, that would be April I'm referring to. You're going to be brewing for up to 72 hours, which is 3 days. There's a lot of conflicting info on this on the webs, but this is, again, according to my research and my experience that I've been doing for a long time, and I found that it does take this long when you're using these minimal foods and it's rather cold out. As the temperatures start to get warmer, you can brew for 2 days. And then in summer months, you're going to be only wanting to brew for 24 hours, or even in super hot places. If you live in the desert or something like that, you'd want to stick to like 12 hours. And when you're brewing, most people aren't going to be using a microscope to check this. So you're going to want to err on the side of brewing for less time. So with this, and I'm trying to get through this rather quickly, but I'm getting into a little bit of details here. We're trying to get to peak populations of microorganisms. So we start off with 1,000. We're trying to grow that 1,000 up to 1,000,000 and reach this peak population. We're going to reach a peak population. And at a certain point, we're going to have anaerobic microorganisms, especially bacteria, at first take over, and it's going to quickly go anaerobic. So we're trying to hit this peak population and reach that peak population and then apply this out onto our plants. So anywhere before that peak population, err on that uphill climb. So err on the side of brewing too less. So, if you're brewing tomorrow and you're like, Troy said that it's going to take like 48 to 72 hours right now, I would stick to 36 to 48 hours, or, stick on the less side so that you're not overdoing it and not going into those anaerobic brews. So when you're all done brewing, the time's up. You're going to want to empty the brewer. If you've got a 5-gallon bucket going at home and you're putting the compost tea out over your beds, you can just pull a little bit off at a time and put it into your watering can and dilute it down. I'll talk about a little bit dilution in a second. This presentation is mainly on brewing, not on application, so I'm mainly sticking to brewing. But so you'd want to leave it on air if you're just pulling a little bit at a time. But if you're pulling all of that brew and wanting to use a backpack sprayer or a spray unit with nozzles or drip nozzles or something like that, you're going to want to run the compost tea through a second filter to get there's going to be a lot of sediment in the water. We still want some sediment, but you want to get a good amount out of that so that it's not clogging any of filters or nozzle heads. So go big with nozzle heads, remove inline filters. It's good to get these chunks out. Like when we're spraying, it's we're actually wanting to get this little sediment and tiny little chunks out in the compost tea out into the soil, because that's going to benefit the microorganisms even more and the soil therefore. So after emptying the brewer, the reason I put this picture up of all pictures is that the most important thing is that you want to clean your brewer. The foods that we're using for compost tea are sticky, especially fish hydrolysate. Fish hydrolysate is going to be super sticky. And if you don't clean your brewer, it's going to likely leave a biofilm on the insides of your brewer or brew parts or brew bag or hoses or anything like that. And this biofilm is likely to create anaerobic microorganisms that are going to affect future brews. So when I worked at Rodale, we had a guy sending in samples that were anaerobic, and he was sending in multiple samples, and it was always anaerobic, and there had to have been something in his system that wasn't getting clean, that was adding these anaerobic microorganisms to his brews because he was following all the suggestions we were giving him, and he was definitely not, brewing over where it should be anaerobic, but he wasn't getting something clean enough. So that's why I stress clean all of your equipment. And the sooner you clean it, the better, and the easier it is. So I can go in right after a brew and just simply use a hose that's running and one of those Scotch-Brite pads. I like to use the little Scotch-Brite green pads. And then, just scrub real quick and everything will come off and rinse away. If you leave it sit for a little while, you're likely going to have to use some type of soap. And I like to use environmentally friendly soap. With your brew bag, it's going to have been sitting in the liquids that's full of fish hydrolysate and humic acid. So it's going to have all this nasty gunk on there, and you're going to want to likely soak your brew bag before you clean it and soak it in some soapy water. And then as far as application of compost tea, this is a living thing. It's a living entity. We've got billions of organisms in here, millions or billions. And so we need to get it sprayed out as soon as possible. So you want to use it within 24 to 48 hours. Use it immediately if possible. So in hotter summer months, you'd want to use it within 24 hours or sometime around there. And then cooler months, you could maybe let it sit if you need to. Just maybe pull your bag off and keep it on air if you're not able to get to it right away. But you want to spray it as soon as you can. All right. And then I had mentioned dilution just a second ago. When we're applying this, so at Rodale, we did application rates of 5 gallons per acre, which is very minimal. If you can picture having, 5 gallons of water and trying to get that out over a whole acre, it's not going to really be possible. So you can dilute compost tea down however much you need into water. So the water is going to act as a carrier to get compost tea out over a larger area. So we did 5 gallons per acre because it's so inexpensive to make. I like to go out with 10 to 20 gallons per acre. And because of the size of yards that I generally spray when I'm doing lawns, it usually ends up being even a little bit more than that. But and then you can dilute down. So say you make 5 gallons of compost tea and you've got 10 raised beds in your yard, and you know that each bed, it takes you 2 watering cans full. So that's 20 watering cans full to water your whole yard every time that you water, or raised bed garden that you, every time you water it. So you would split the 5 gallons up amongst those 20 watering cans full. So if you've got 20 watering cans that you're filling, just take a little bit off, split 5 gallons up amongst those 20 gallons. Or, if you've got a 50-gallon tank and you're doing an acre at 10 gallons an acre, take 40 gallons of water and 10 gallons of compost tea to get your 50 gallons and dilute it down. So just dilute it down however much you need to. With that, I will go to questions and answers. And I think that Steve was going to bring up a few here, and then we can take some from the audience. You're on mute.
There I am. Now I'm unmuted. So I had a few questions for Troy. I think you actually answered a few of them. And I think you just did a really good job of explaining dilution. That when I first learned about tea, I go, why don't you just apply it as is? Why would you need to dilute it? And you told me, and just correct me if I'm wrong, the water, extra water, you've got the same biology, but you're just the water is your vehicle. And the more vehicles you have to get it down into the soil, the better. And often the more water that goes in, the more it's able to be absorbed into the ground. Is that correct?
Correct. Yeah. So when I'm spraying out on a lawn, a lot of these microorganisms can be affected by UV light. And so if I were just to spray a very minimal amount of compost tea out over a lawn and it just sticks, a minimal amount sticks to the foliage and doesn't really get down to the soil, it's going to have some effect, but the UV light from the sun's also going to have a negative effect on there. So on top of that, like if you have, I used in the article I just wrote the analogy of a sponge. If you have a dry sponge that you stick under your faucet, when you first immediately do that, the water just pours off and doesn't absorb into the sponge. But if you have a moist sponge and you pour water onto it, then it immediately absorbs more liquid. So in that sense, with the soil, I'll go out with 300 gallons of water or 270 gallons of water and 30 gallons of compost tea and spray, way overdo it with the water because I'm wanting to get that soil moist with the extra water so that I can have more absorption of compost tea and get it to work into the soil more. So I'm getting a good foliar coverage and getting it worked into the soil. So it's going to benefit the roots of the plant.
Okay. One thing I know you covered on one of the blog posts is that there's really no such thing as too much compost tea, but you did find one of your customers that actually burnt her plants by adding tea, but it was because she was using another amendment with that. Can you explain that one?
Yeah, the first part of your question was about using too much compost tea, or you didn't necessarily ask a question, but you mentioned that. So yeah, you can't really ever overdo compost tea. To use an analogy, just say you have a city of 1,000 people and you have enough food that can support 1,000 people and housing that can support 1,000 people, and then you throw another 5,000 people onto that. Well, if you've only got enough food and environment for 1,000 people to survive, that other 5,000 is going to be added, but at some point they're going to die because there's only enough supplies to support 1,000 people. So if you've got these populations in your soil and you're adding more and more populations to them, at a certain point, it's not going to overdo it. They're just going to die, or they're not going to repopulate or whatever. You can't really it's not like nutrients. It's not like NPK fertilizers where you can spray too much nitrogen and burn the crap out of your plants.
Okay.
With compost tea, strictly with compost tea. And then your question was regarding a customer that I had. So I did a compost tea spray for a lady who had some raised bed vegetable and flower gardens. And I showed up with my sprayer, sprayed her plants, sprayed her soil. And, it was the middle of summer. She had some tomato plants that were, I don't know, like 4 feet tall or something like that. And I checked in with her several days later because she's my daughter's friend's mom. So I just wanted to text and see how things turned out. And she had mentioned that I'd burned her tomato plants. And I didn't argue with her, but I politely explained, that I'm using, a half a cup of foods that would have nitrogen in them in 50 gallons or, in 30 gallons of water, and that's getting diluted into 300 gallons. So I've only got like 1 cup of nitrogen containing stuff in 300 gallons of water. Like, it's pretty much impossible for me to have burned your plants. And I asked her if she had applied anything other than the compost tea. And she had mentioned that a couple days before me coming, she had ant issues. And she had read that if you sprinkle blood meal around the base of your plants, that will help to control ants. So she had sprinkled a good amount to get rid of these ants. Well, then I came and sprayed compost tea, and all that biology, the bacteria just munched away at that the blood meal and immediately activated it. So it activated it, sent all that nitrogen up into the roots, into the plant, and burned her compost.
So it's the activated blood meal. It's not the tea. It's just the fact that you activated the blood meal.
Right. Yeah. So I activated the blood meal, which was a bad thing. But you can also take advantage of this. If your plants appear to have some sort of deficiency. If you planted something in the spring and it's yellowing and it appears like you don't have enough nitrogen, you can put a nitrogen source out, just not a ton of it like this lady did. Yeah. And then spray compost tea over it, and it's going to activate that nitrogen, and you're going to get those nitrogen into your plants to get the benefit from it.
Cool. So I'm going to skip my questions, which I think I want to get to the audience's questions. We got, looks like 16 of them. Some I think can be kind of condensed down. Let's kind of handle this rapid fire a little bit.
Yeah.
And I'm going to handle what I can. I'm just going to handle these in the order in which that they came in. So Kay Crumbach asks, can you create a compost tea that favors creation of fungal spores or is otherwise fungal dominant? I would imagine that the fungal nature of the tea depends on the fungal nature of the compost or vermicompost that you're starting with. Is that correct?
Yeah, and I realized I didn't fully explain that before. Was that we're adding fungal foods, and the idea is that there's tiny hyphae from that are attached to the compost that we're pulling out into the water, and we're feeding them. When we've got all this agitation going in the compost tea, you're like, one thing that people talk about with soil food web knowledge and things like that is that the problem is that tillage and plowing and disruption of the soil is going to break up this fungal hyphae. Well, if you use that same thinking, you can't put fungi into a brew that you're agitating and expect the hyphae to like subsist or grow or anything like that. That's not possible. So we're adding foods for these fungi. So then once we spray these tiny little fragments of hyphae onto soil or plant surfaces, we're giving them food to then take off once they get to their destination. So we're not growing the fungi within their brew. Fungi in compost and compost tea, it all starts with your feedstock. So the more fungi you have in your feedstock. So there's a guy in Southern California who I worked with, and he was getting feedstocks. He was getting all this old trees, not old growth forests, but old trees from very old trees from a park somewhere. I can't remember what park it is, but it's in Southern California. So it was just filled with fungi. So he's got this fungal dominant compost. You can help when you have a compost, you can help to feed fungi in the compost. But yes, when you're having a compost tea brew, it's all dependent on how much fungi, or if you have any fungi in your starting compost or vermicompost.
You can't multiply zero.
Right.
And expect, okay. So this next question it's a little, let me not put it. Jonathan is another soil food web. He's with Dr. Elaine's group, and says that, and I'm not trying to start this cable news fight online, but said, I'm a soil food web consultant. We have moved away from teas, lots of issues with it. Compost extracts are more consistent and pragmatic. Now, you probably spoke to some of that. I think we know that extracts, which are really non-agitated teas, right? And non-food, they're agitated, but we're not blowing up the population. Those would be more stable or shelf stable, right? For a longer period of time, they would just have lower biology. But can you speak to his point that compost extracts are more consistent, pragmatic? Is it something you agree with, disagree with?
Yeah. So I'm actually writing an article on extract right now. The research that we were doing at Rodale actually involved extract, not compost tea. So when I said that we were doing research, we were doing with compost extract most of the time. There's a whole lot of details I could get in with that. Compost extract, it is going to be easier to make if you've got a business where you're brewing compost tea and multiple people are involved. When you're making a liquid compost amendment, and you've got multiple people involved, it's easier to do an extract because timing and things like that. And then also, you're not getting this peak population, you're getting a population, and that's what you're stuck with. And so that's not maybe the best term, but that's what you're going to use that's in your finished product. So it's easier to have I wouldn't say I want to bottle it, but you can keep it for 7 or 10 days. It's been shown to keep for 7 or 10 days at least. And even with not having it on air, you can increase protozoa within that. But the whole so compost extract we're going to get into that in the future articles, and I'm excited to bring that to people. And it is easier, and I would agree. Elaine talks about it a lot. The whole reason that we're getting into compost tea brewing today is that with compost tea brewing, you can get so many more microorganisms and get a lot more effect from that. So,
okay, cool. Let's see. White Davy asks me if I've ever considered doing a virtual conference. Haven't considered it much. When it looked like that the North Carolina State Conference was not going to go on, I was considering hosting one up here. I really think that it's small enough niche, that the warm world's small enough. I don't want to step on what Rhonda's doing at North Carolina State. I'm going to be down there anyway. But it's something I have considered doing a real conference, not really a virtual conference, but that's an interesting idea. So I think it would be probably pretty well attended. So I'm interested by that idea there, White. So thank you. Carolyn said, let's see here. It sounds like Carolyn was asking about leachate. It sounds like she's come to the realization that what she thought was tea is leachate, and wondering if it will help the plants. And I kind of told her in a comment, like, leachate isn't necessarily pathogenic. You just don't know what's in it. It's it's kind of mystery juice. Leachate tends to be just the stuff that breaks as the water inside your food waste breaks down. Or I'm sorry, as the cell walls of your food waste break down, it releases a lot of water. Most fruit and vegetable waste is about 85 to 90% water. It just releases gobs of water that you just didn't think were there before. As that leaches its way down through your vermicompost, it comes out of the bottom if you've got a stackable worm bin, or it might drip out of the bottom of your urban worm bag if you got the bottom open. So I just say, she asked, should I use it or should I discard it? I'm like, I myself would discard it, but a lot of people swear by it. They love it. I just have to say that it's not tea for the purpose of this conversation. Trevor asked where you obtain all of the bacteria and fungi. Well, that would be in the compost. So the point, and this is kind of goes back to an earlier question, which is the bacteria that you have in your tea that you're multiplying ultimately depends on the base material you're starting with. So that, Trevor, those bacteria and fungi are not like added into the system like by something you buy. What you're doing is you're taking that compost and vermicompost that has the bacteria and fungi, and you're multiplying them. What you're really multiplying are the bacteria. It sounds like the protozoa, the nematodes and the fungi really can't be multiplied quickly at all in a compost tea. Troy, did I say anything wrong there before we go on to the next one? Okay. Melissa asked an interesting question. I think I know the answer, but we eat lots of fish, and can I use leftovers and ground up leftovers of fish guts and stuff, shrimp shells, salmon skin in compost tea, or that stuff that should just be composted or bocaccia'd or something like that? What would you think about somebody actually using that in a compost tea? It's a wild. Is it a wild card? I mean, you don't. It doesn't have to have a definitive.
So when people are making fish hydrolysate, they're blending up a fish, but then they're putting in stabilizers so that it doesn't go bad, and they can bottle it and sell it. So if you did that, you would want to like blend it up and then use it. You wouldn't want to keep it for real long. Mm-hmm. Some people do the KNF fermented fish juice. I don't remember exactly what it's called.
KNF is Korean Natural Farming. Is that correct?
Yeah.
Okay, gotcha.
Korean Natural Farming, or JDAM, is a similar practice. There's some type of fish thing that they make with that's supposed to be similar to fish hydrolysate. But yeah, you could. I would say that you should be able to ground it up, but you're mostly eating a lot of the things that you're wanting. The fats and the oils are going to be in the meat that you're eating. Mm-hmm. So
yeah, we'll just say we're going to leave that one alone and not provide a recommendation for or against. But probably if we're not saying yes, do it, it's like maybe don't do it, because it sounds like it's a wild.
It would probably be best to put it in the compost if it's just the leftovers.
Right. Let's see. Melissa says the aeration process is where I have trouble, and I hope that this shows something easier than what I've seen so far. The one interesting thing about the aeration is that, well, a couple things. Troy recommends against using air stones. Well, so we're pumping water into the water, and we're not just agitating the surface. This is something I learned from Troy, is that with compost tea, you need to have the whole column of water be oxygenated. So you're not just trying to like agitate the surface and call it good. the stuff has to really kind of be fully, like full column agitation there, Melissa. So you're going to want to anchor that air pump or anchor the hose down in the bottom of your tea brewer. Do I have that right, Troy?
Yeah, the where the air is coming out, the end where the air is coming out, you're going to want to have at the bottom of a tea brewer.
Yeah. And so I'm not sure, it said, hoping something easier than what I've seen so far. I mean, there's really, all it is you could probably take a brick, not one that would actually crush your hose, but something that just can anchor that thing at the bottom. If all you're doing is putting an air hose at the bottom of a 5-gallon bucket or a 55-gallon barrel, you just want that thing to be at the bottom so it bubbles all the way up. You're not just trying to create this like agitation at the top. Somebody asked, heard that it's good to water my worm breeding beds with compost tea. Do you know of any real benefits to this? I don't know of any benefits to it. I mean, adding biology is probably a good thing. I would say that worm breeding beds tend to need to be wetter than normal vermicomposting environments if you're trying to promote breeding and reproduction. But I'm not sure if actually watering them with tea makes enough sense to make it worth the hassle. Let's see here. Laura asks,
can I chime in on that one?
Yeah, please.
We were just talking, Steve and I were just talking about worm diets or whatever worms eat before we got on here. And how a lot of people don't understand that it's the microorganisms that break down things in a worm bin or compost pile. The worms are assisting in that. So they're shredding down material and helping to inoculate the material with more biology. The worms are getting their nutrition, so they're chomping away at a little bit of watermelon. Well, on that watermelon is these bacteria and protozoa, and the worm is chewing through the watermelon, but it's actually gaining its nutrition from bacteria or protozoa or whatever on that surface. So they're gaining their nutrition from the microorganisms. So by applying a compost extract or tea to a worm bin, you're going to up the biology, which would essentially give worms more food.
Worms more food, but this is for the worm breeding beds. Like, does it spur breeding?
I don't know if it would spur breeding, but I mean, giving something food's going to give them more energy to breed.
True. Okay, cool. Thank you for that. Let's see here. Laura asks, Laura there, worm return there in Pittsburgh. With the air tubes, what's the best way to clean those, or should I replace them with each brew? I don't think you necessarily replace them, but you're running like warm water through them, soapy water. What are you doing with the tubes? So when I probably failed to mention that. It's just one little trick. Before you put your air hose into the water, turn your air on so that there's air coming out of the tube. And then when you put that into the liquid's not going to be coming up into the tube because the air's coming out. So as long as you keep your air on while you have the tube in the liquid, you shouldn't be having to clean a lot on the inside of the tube. Maybe just the very end, you'll have to wipe out a little bit with your finger. Other than that, you can just take your the thing that I get it. And I was about to do the motion and I didn't want to do it. Well,
you can just clean the outside of the hose by scrubbing the outside of the hose with whatever.
Right. Yeah. And then on the reverse, you're probably taking the hose out before you stop the pump.
Yeah. So pull the hose out and then then cut the power.
Gotcha. Well, Troy, this is a family show here. What do you
whip your hose
up. If using as a foliar spray, does it need to be diluted? Robin asked this. I think I don't think it needs to be diluted. It probably just depends, right? How much do you have and how much do you need to apply? You
don't have to dilute, or you can dilute. I mean, it's really with compost tea, it's whatever you need to do. So it's not going to be too strong to apply compost tea straight onto your plant. You just want to, mist it a lot quicker than if you were to have diluted it down. Then you can really soak it down well.
Okay. Melissa asks, she puts it in quotes, keep air going. And this is an area that's over my head. I think, Melissa, I think you might be complicating things. By keeping air going, we mean keeping the air pump on, which is delivering air to the bottom of the compost tea brewing apparatus, whatever that it is that you're using. What Troy was talking about is that if you are going to not be using it all at once, then take some out. You're going to pour it into whatever you're going to use to spray or to pour on your plants. Keep the rest of it agitating and being oxygenated, because what's going to happen is those microbes inside that tea are going to consume the available oxygen. And if you're not feeding them more of that oxygen, then your tea will go anaerobic. So when he says keep air going, that's all we mean is keep that air pump on. Roger asks, and this is a good question, and you've covered this on a blog post, Troy, but how much airflow is needed? I tried it with a small aquarium stone in a 5-gallon bucket, and it went anaerobic. What do you recommend? I know you've got a really good rule of thumb for how large of a pump you should use for how much tea that you're brewing.
Yeah, so I'm not an expert on pumps, and it's going to be dependent on the shape, but usually with some type of cylindrical shape. And when we're brewing like 50 gallons or less, you can go by a rule of thumb of, so when you're looking at a pump, most pumps have an output on the box or whatever that lists their output, and generally it comes in liters per minute. So if you have 1 liter per minute for every gallon of compost tea that you're brewing, that should be a good amount of air that you need, that it's going to keep it aerobic or above 6 parts per million of dissolved oxygen, and you're going to get a good amount of agitation. So you can go higher than that. That would be kind of a minimal rule of thumb. At a certain point, you can get a lot of air going where it's just beating up the biology and you're just getting sloshing and too much agitation. But yeah, so good rule of thumb that I found. So like 5 gallons, around 5-6 liters per minute, 50 gallon brew, 50 to 60 liters per minute.
Gotcha. So
for the output.
Yeah, not gallons per minute, but liters per minute. So we go, metric versus American.
Yeah.
So metric versus English. So
yeah.
So liters per minute to the gallons, it should be right around 1-to-1, and that's the appropriate size pump. Okay. Rob, this is a really good question. Rob Boss asks, would it be ideal to apply compost tea when the sun isn't out to minimize UV radiation, killing off some of the microbes when you apply?
Can you repeat the question?
Yeah, so he's suggesting, would it be better to apply your compost tea maybe at night or at dusk when a lot of that UV is not out?
Yeah, so I usually try to go out early in the morning. So the underside, the stomata on the leaves are the most open in the morning time, and that's where they absorb nutrients on the foliage. So the earlier you can go out and spray, the better. Or you can spray at night. It depends on the plant and on the environmental factors, because you wouldn't want some plants to be sitting moist overnight because it can cause fungal issues.
Okay. Let's see here. We got a few more here. Let's see. Jacob asks, how long will a tea stay biologically active, and how do we know this? If you had to put an expiration on it, how long would it last?
It all depends on the temperature outside and the amount of foods and the amount of biology that you started off with. So there's a lot of variables that it really depends on. So that's why you have to kind of stick to rule of thumbs.
Okay. Let's see here. Is a pond pump aerating enough with hose water pushing up into the air? A pond pump, I would imagine, if it's aerating an entire pond, would be enough, enough airflow. But this cat walker is asking this cat, I would just say to stick with at least having a 1-to-1, if not more, liters per minute airflow for every gallon that you're trying to oxygenate. Let's see here. Jonathan brings up a point that you've made already, Troy, is to not use air stones for oxygenating water. We're not trying to create a bunch of tiny bubbles. We're trying to create a powerful agitation of the water, and so you don't want to diffuse it. And the other thing is that that's not the real point. The whole point, Troy, correct me if I'm wrong, and I'm wrong often, is that the stones act, with all those little nooks and crannies, act as a breeding ground for biofilm and gunk and pathogenic crap that wouldn't want in your compost tea. Is that correct?
Yeah. So you've got all that porous material, and it's sitting, soaking in foods and microorganisms. So, I mean, even after the first use, it's just going to soak up a bunch of stuff that you're not able to clean out. And they're really unnecessary. People use air stones in aquariums to diffuse air and make more bubbles to spread out. But the same amount of air comes out of the tube, whether or not you have an air stone on it. We're just taking advantage of the air. So it doesn't matter if we have big bubbles or tiny bubbles. We just need to get the air into the water. It doesn't matter if they're tiny little bubbles. They look pretty, but yeah, we just don't even need air stones. The air stones are nice because they add weight to tubing, which holds it on the bottom of the brewer if you're using a 5-gallon bucket. But I've used something simple. Like what I do is I find forks, because I do food scrap composting. People accidentally throw away forks, so you can just stick that 1/4-inch tubing in between your fork tines and drop the fork down into the bottom of the bucket, and then it's super easy to clean when you're done.
Cool. Vermicompost, learn by doing. It's actually a really good YouTube channel. Go check it out. After you subscribe to Urban Worm Company, of course. Asks, I see this is a really good question. I see small clumps of dark brown gel-like substance the longer my tea brews, like 36 to 48 hours, he says. Is it biofilm, or is this substance good or bad? Do you know what a gel would be in a compost tea?
I've never experienced that. I don't know what that would be.
Okay. All right. Well, hey, something we didn't know, something you didn't know.
Yeah.
So Zachary Jones, Dr. Zach Jones, just chimed in. Thanks for joining us, man. I want to put a special mention. We just published an interview post with him. This is really cool crap that he's doing, which he's already conducted this study. And I think we're going to go for another grant for a much bigger study where he is sequencing the DNA of vermicompost. Just sort of like 23andMe for vermicompost. Now, we all know that compost and vermicompost doesn't have mommies and daddies and a lineage that we can go look up on Ancestry.com. But the vermicompost is made of life, or has plenty of life in it. And by sequencing, that life is made up of proteins, and that protein can be sequenced. And we can find out not just that we have bacteria and fungi, but what species of bacteria and fungi that we have in, so we can get a much more granular look at vermicompost. And what Zach is doing is really cool. There's the most recent blog post we have at urbanwormcompany.com is 23andMe for soil, and it talks about what he has done. I do an interview with him, and we have a sign-up sheet on that. We have kind of a sign-up form on there for you to be notified when we get this grant approved, and we will have you guys submit your vermicompost samples to our to us, to Zach. He's going to run them through. He's going to give you the 23andMe for your worm castings, which is so cool. I got mine. I will tell you that if you looked at just one sample, it means nothing. But if you look at your sample in relation to everybody else's sample, you can sort of see, okay, mine looks like a lot of other people's, or it doesn't. And so it's really kind of interesting what Zach is doing. So thanks for checking in, Zach. Rob Boss asked another good question. Do you, and I think he was asking this to both Jonathan Moore and you, but do you use one of those cone or cylinder type containers to get brewing for more agitation? And I know you like the cylinder stuff, Troy. So can you speak to why you like cylinder shapes, which tend to be commercially purchased, but why you like those more than you might like a 5-gallon bucket or a 55-gallon barrel?
Yeah. First, the shape of the conical tanks. I'm just going to draw a quick picture. So with the conical tanks, where the heck is my camera?
You can turn off your light, maybe if that's
yeah, with the conical tanks, you're able to plug the hose up to the bottom here, so the air is guaranteed to go through all of the water, the entire column of water. You don't have any pockets that could go anaerobic. Is one of the reasons that I like to use conical tanks. The other is the ease with which you can go between hooking up a blower or air pump to the bottom of the tank and then turn off a valve to close the bottom of the tank. So, yeah. So you've got a hose that's hooked up to here that's pushing air up into there. And then there's a valve here that you can cut the valve off. That's not going to allow any liquid or air to go down or up. And then you can gravity feed, take the hose off of the air pump, and then use that same hose that was hooked up for the air pump to empty your compost tea brewer into a spray tank. So the main reason I like it is due to you're surely keeping everything aerobic, all the contents of the brewer and the liquid. So the idea behind the air going through the entire column is that you want all of that water and liquid to be getting oxygen and staying above 6 parts per million dissolved oxygen.
Numbers. You said numbers. I just tuned out there for a while, Troy.
It's cool.
Cool. So I tell you what, I think we may be coming to the end. We'll stick around and answer any more questions that you guys have, whether it's about worm bins, worm compost, compost tea, organic stuff. Just let us know. I will wrap up with just a couple things. I think today went really well. I had a lot of fun with it. We've gone over an hour, and we've still got people watching and commenting. And so I think we need to do this again, Troy. I know I've done a couple on my own, but it's great having you along to provide some of the science that I'm really not able to. We're thinking about doing this again on May 3rd at 11. If you are on my email list, that's the easiest way to find out that we're going to be doing this again, or subscribe to the channel, and you're going to be able to be notified when we go live. I think you can hit subscribe and then hit that little bell that says when we're going to go live. That's on YouTube. And I think if you like Urban Worm Company or follow us, then you're going to be updated on these. The other thing I will tell you is you can go to you can join the Urban Worm Bag learning group on Facebook. You don't have to have an urban worm bag. All you need is a desire to learn about worm composting, soil, any of this good stuff that we're talking about. And I always post on there when we're going to go live and kind of set a reminder. So love to hear any comments that you've got about, how we did here with this. If there are things you want to hear about in the future, or topics you'd like us to cover, whether you liked it, whether you didn't like it, that would be great. I'm going to get to a couple more questions here. Do you have a brand, Troy, that you prefer for soluble kelp?
Yeah, I saw that question. I was about to answer it. True Aquaponics has a powdered form of soluble kelp that I like to use. It's a good deal and it's a good product. It's True, as in TRUE, trueaquaponics.com. I think they're based out of Texas. Okay, cool. Kat asks, can you use the same pump that might be used with an ASP? I would say that is a lot of air. I'm going to say no, like you'd just be tearing apart be tearing apart any fungi, right? For something that's just too much airflow, right? Well, on 100 gallons and more, you would be using a blower, but you'd be using a regenerative blower. To be honest, I don't know. I know that they are different. I know a regenerative blower is different from the bouncy house type blower that you use for ASP, because I have used both of them. So the blower that you use for ASP is going to be 1/2 or 1 horsepower. It's got the same power, but they only cost like $100, whereas these 1/2 and 1 horsepower regenerative blowers that are going to put enough air into a brew tank are going to be $600, $700, $800.
Okay. Yeah, that's a big difference.
Yeah.
So cool. Well, guys, I think we're going to wrap it up here. We've been at it for over an hour. Troy, thanks for joining us. Everybody that's out there, thanks for joining us. I see people from all over the country. We got Canada, we got South Africa. We saw some folks chiming in from Europe. This was a lot of fun. So right now we're tentatively scheduled for May 3rd to do this again. That is what I believe next. Did Tuesday. I say Tuesday? Next Tuesday, we'll think about doing this again at 11 a.m. So cool. This is going to be posted on Facebook. It's going to be posted on YouTube. Just check our channel. You're going to be able to see a replay of it. If you happen to miss it, or if you're just checking in now, you can watch the whole thing. So guys, we're going to end it there. Thanks so much. You can keep commenting and we'll get to those questions maybe on the next live stream that we do. So Thanks, everybody. We'll
Thank
see ya.
you.